Hi everybody. Last time I installed the Longhorn based storage system for in Kubernetes, and this time instead of Longhorn we are going to replace with the Chef based storage system. So once we done this work, after that whatever the volume will be created, it's created by the Chef file system. So I'm going to install the Chef. This Chef is a lot of features are there and it's also complex. So, and in this video and Chef I have provided the object storage, block storage and file system. Block storage is provided by the RBD and file system is provided by the Chef FS, and object storage is it's like the S3 compatible object storage. In this video we are going to use the block storage and file system. In my future videos I'm going to cover the object storage and how to use the Java applications to connect the Chef object storage using S3 APIs. And the difference between the block storage and file system in terms of Kubernetes, whenever RBD or block storage create the any volume, that volume is mounted by only single pod, so exclusively mounted or binded to single pod. But if you create the any volume using the ChefFS or Chef file system, then that volume can be mounted to multiple pods. It's like we can see the NFS, you can mount it to the multiple pods. So that's one of the advantage of file systems. But if you want to more throughput, you need to use the RBD. Okay, we'll see that. So installation of Chef is difficult. So there is one project is available, open source project called rook.io or rook chef. This what they do is they taken the entire Chef module, make it as a Kubernetes compatible. So it's we can install like a bunch of YAML files. You can install the rook chef or chef in our systems. So we are going to use this only. So this is a website, and go to the documentation, Chef, and we'll see the quick start guide. So before going to that Chef, if I already install anything, we need to check the rook chef cleanup document. So we need one unpartitioned hard drive we needed for the Chef installation. Chef installation not like installing the already existing hard drive or formatted storage, they won't use it. So we need one external hard drive which is unformatted. Everything Chef will handle everything A to Z. So suppose if you have the old hard drive, so I mean that hard drive you already formatted as something mounted, we need to zapping the devices. This is a procedure given by Chef. It's nothing, you need to mention that which hard drive /dev/stb or stc. So mention the which disk you want to utilize, give to Chef, then execute this bunch of command, then that hard drive will be automatically all the partitions are removed, and it's like a normal unformatted hard drive is created by these commands. So you can check this troubleshooting guides if you wanted. Now we are going to see that one. I'm using the just me and open source. He created the Vagrant based scripts. So I'm using creating Kubernetes using this time Vagrant, because we need some extra hard drives are needed, so it's not possible for the physical systems. So we created the virtual system VMs using the Vagrant, and then we are using the connecting some external hard drives. So that I am already running some systems are running. So first we need to shut down all the Vagrant. So now they shut down one by one. So we first go to the VirtualBox. Now you can see that key worker 3 is shut down. So we'll start with that. Those VMs are shut down. We'll add the hard drives. Let's go to the settings in VirtualBox and go to the storage section and add the SATA controller. Give the plus, click the plus icon, and keep the VDI as a default and dynamically allocated. So dynamic allocated is kind of a thin provisioning. So for example, I mentioned the 200 GB, but internally they won't assign the 200 GB. It's a very limited, like around 2-3 MB only assigned. So whenever data we are adding this hard drive, that file sizes keep on growing. So I created 200 GB hard drive. I actually, due to the some remote desktop, I can't see clearly, so click one more time. Now it is a created, so you can see that here the virtual hard drive size is 200 GB, but actually they're using 2 MB only. So select that hard drive. So that hard drive is added here. You can see here that hard drive is added. Click OK. Now repeat the same procedure for other nodes except master. Master no need to add, only for worker node only we need to add. So the last hard drive I also added. So hard drive is added. Click OK. Now K worker 1, worker 2, worker 3, all each node I added one 200 GB hard drive. So I think that's done. So now Vagrant is up. Start all the VMs. It takes some time. Okay, now I restarted. Now we'll see that first master node. So Vagrant SSH K master. I want to show that the hard drive which we connected. So type the command lsplk. So show all the block devices. You can see here there is a SDA is there, and they have 3 partitions. One is the boot. This is a hard drive mounted for the OS purpose, but there is no extra hard drive is available. There is no STB is there because we not connected the extra hard drive, not in the master node. So come out that one. Now connected to any one of the worker, because we connected each hard drive to each worker. So can connect any worker. Type same command lsplk. You can see here there is one extra hard drive is connected. So it's mounted as a showing that disk drive name is a STB, and it is a 200 GB hard drive, and it's not a partitioned or formatted anything. So that's okay. That's what we needed for the Rookchef installation procedure. So now our system is ready. Now we are going to install the Rookchef. So this is the command they given. So you can check the rook.io, copy, clone that repo, GitHub repo, and I'm using version is 1.10.2. So that's important. So second is they're saying that go to the rook deploy example. So I'm already rook. So cd deploy and example. So here the third command is we need to install the crd common operator. So before installing, we'll see what those files are. So first is crd So CRD is a custom resource definition file. So the rook, once rook chef clusters are installed, there is a multiple custom resources are created. So like a chef fs or block storage like this are created. So that purpose this file is used. Second file is common.yaml. So common.yaml is creating the namespace and creating the cluster role and cluster role binding. So all the permissions relevant to RBAC. And third is operator. So install the operator. So we'll see that what is the operator doing. Operator.yaml. So operator.yaml is using operator pattern. So they install one operator. From the operator we install the chef storage. So operator we can modify. So now the recent chef, they provide the inbuilt NFS servers. So if you want or not, by default no. I enable it. If you want to enable it, you can enable, otherwise we can make it disable only. And chef providing the encryption also, like all the persistent volume will be encrypted. But for this, if you enable it, you need the key management system like a HashiCorp Vault need to be configured. So I don't want that part, and leave it as it is. Remaining things. One important thing relevant on this one is this one, rook CSI kubelet directory path. By default they're taking place from the var lib kubelet. I'm using the vanilla Kubernetes, so it's not a problem because the same place only my kubelet will be there. Suppose we are using K3s or K0s distributions, this path may be different. For example, in the K0s, the path is /var/lib/K0s/kubelet. So in that case, we need to be change the path. If it's a default path, no need to enable it. That's by default that location only they're searching. I think that's important for this one. So now we need to install that our operator. So now installing kubectl apply -f, first crd.yaml, then next file is common.yaml, the next file is operator.yaml. So the CRD have custom resources, and common is a role bindings, and operator is one operator controller will be created. So you can see that in the K9s GUI tool namespace, check the namespace created called rook chef. In the rook chef, there's one pod will be creating. So it's not clearly visible. So there is a operator pod is creating. So wait for a little bit time. Watch statement. Okay, now rook chef operator up and running. Now we'll see that install the cluster. Now we are looking at the cluster file. So it's cluster.yaml. Cluster.yaml, you can mention that in the comment section. So first is CRD file, common, operator, after that cluster, because it's how the kind is chef cluster. So by default this kind of kind resources not available in the vanilla Kubernetes cluster. And so when I install the CRD, so lots of custom resource definitions like this are installed, like a chef cluster, block storage pool, and chef file system, like this. Lots of custom resources are defined. So this is one of the custom resources. So this is only you should install after operator, because whenever we are deploy this cluster.yaml, this will directly go to the operator do all the jobs. So here we have using the chef 17, so that's the images we are using, and there's a data path in the /var/lib/rook. Some metadata information will be stored, So when you clean up the root chef cluster, we need to delete this directory location on each worker node. So that's here important. And apart from that, there's a here they mentioned that how many monitoring pod will need to run for the chef cluster. So here 3 monitoring pod will be running and 2 manager will be running. Again, these all are part of the chef terminology or chef architecture. And below that there is a dashboard, so there is a graphical user interface available, so it's by default enabled and it's running on SSL, so it's running on HTTPS, but I'm putting HTTP. I don't want HTTPS, I want to run unencrypted because in future videos I'm going to integrate with Istio, so Istio will provide extra additional SSL layer. So right now for that purpose I make it SSL is a false, and nothing need to be changed it. And if you go below, there is a one section called storage section. Yeah, here when you see the storage section, here mentioned as use all node is a true and use all device also true. So it's mean that all worker node will be participated in the chef cluster and use all devices. So whatever the unformatted devices is there is go for auto discovery mode, and if you figure out more than any whatever the hard drive, suppose in this our case only one extra volume is attached, suppose we attached two volume, so it is automatically discovered and use it for the chef cluster. So that's the purpose. If you don't want to auto discover mode, you want to be mention that yourself manually, then go this section. It's a commented that section. When you see here the node, which IP and which device name, like here STB, like that you need to mention in each and every node. So again, this is completely manual process, but we are going automated process, so automatically auto discover mode. So we are going automatic discover mode. So that's it. We change, save it. So we are going to run the cluster kubectl apply -f cluster.yaml. So remember, this will be chef cluster. There's lots of pod will be created. That's operator take care creating all the pods. So if you see in the watch statement, now we can see the lots of pods start to create. So the important information is manager pods and monitoring pods will be created. On the down the line, there will be very important called OST pod will created. These OST pods are very important. This pod only take care of the each hard drive on OST pods are created. So that OST pod is responsible for take care that entire hard drive. So what are the data stored, everything will be taken care of. So that's very important. If it's OST pod not created, I mean your chef cluster installation somewhere failed. So we need to go for a cleanup procedure properly and reinstall everything. If OST is created, I mean our chef installation process is completed. So we'll go for wait for that. Okay, here you can see that there is a OSDs are created. So I have 3 extra hard drives attached. So 3 OSDs created. Now what we can see that now we'll check the chef clusters or status. We'll check. So in the example only there's a toolbox is there. So ls toolbox. So there is one toolbox.yaml. So apply that one. Toolbox.yaml. It is a chef client is installed. So it's not a key. The alias is not there. So kubectl apply. So I have the K9s is up and running. So K9s. So we can through graphically we'll see that. Namespace root chef. So there's the chef tools are running. So this one. So press yes. Now we can type chef status. So here we see that three monitor nodes are running, and there is a two manager, one is active and one is a standby. And OSD, we have three OSD, but only two is up, so we can see it outside. Control D, you can see that one OSD is right now it's still in the not ready state, so still is running. So after some time you will see that all the details. So again press yes. Now chef OSD status. So here you can see that right now only two OSD is only running, so that's why we put only two. But after some time, if you see all three OSDs up and running, you can see that there is each OSD is 200 GB is connected. So that's the things we want to show that. So wait a little bit time. Let's see that this OSD what is state. So instead of before waiting, let it that running. It takes some time to OSD to comment online. So we'll do some other activities. Okay. Now everything ready. Then there is a folder called CSI. In the CSI there is a three folder. One is RBD. Another is ChefFS. So first go RBD. In RBD there is a storage classes are there. So whenever Kubernetes any volume is created, I mean persistent volume, PVC or anything coming, then there is a storage class needed to solve or to provision the volume, persistent volume. So for that purpose storage classes is there. So for the ChefFS we need to install the storage classes. Okay, this is not a storage class. Actually, we are talking about storage classes here. This is a storage class. So here we can see the storage class. There is a two YAML is merged together. So first is create the chef block pool. So here first we created one chef block pool, and the name is called replica pool, and the replicated is 3. So whatever the data we created, 3 times replicated. This is a one way. And after that we create one storage class, and the storage class name is rook chef block. That's a storage class, and we mentioned that pool. So here pool is replica pool, that is we mentioned here. So this is a storage class name. So whenever this storage class is responsible creating the volume, they using via this chef block pool, so automatically data is replicated 3 times. We have other option also. One more storage class is EC or eraser coding. This eraser code using the Reed-Solomon algorithm to provision or use the store the data. So instead of 3 times copy the data, only some parity bits are stored along with the original data bits. So when you go EC, they have similar features. There is a chef block pool is created. In the chef block pool, we are mentioning some eraser coded. Here it's a 2:1. So 2 data chunks stored, 1 code chunks are stored. There is a multiple options are there. You can see the Reed-Solomon calculator. You can see that how much usable data we can able to get out of total storage capacity. So again, we can go this approach also. So it's up to us to which one you want to go. So we are going old replicated model. So I'm going to create this one. So now let's see that. Let it. This is running, not issue. Now go to the CSI RBD. Now before go that kubectl get storage class SC. Now we see there's no storage classes are not there. So whenever any persistent volume is you are creating, there is no storage class to fulfill that needs. So now we are going to create the storage class. So kubectl apply -f storage class .yaml. So now there is a chef block pool created. That block pool is again one storage class that is referred to this block pool. Now you asking the storage class. Now one storage class is ready. So this is the storage class name is rook chef block. That's a storage class, and this is for block storage class. Now we go for another one is called ChefFS, chef file system. So the difference is this storage class, whatever the volume created, is exclusively mounted to only one part. So we other way are called read write once, RWO. Then other ChefFS, that another storage class we can able to create. That storage class, whatever the volume provisioned, that volume can mount to the multiple parts. So it's go under the category of rewrite many. So now we're going to create another storage class. So come out a little bit, go here, chefs. So chefs, there is one storage. So instead of RBD, we'll go chefs, and there is a one storage class. This storage class, based on the fs name is myfs. Again, we need to create the chef file system. That is not part of here. They're not merged together here in the chefs. So it's come outside. There is a file system. So in the root folder, there is called file system. Similar, you can see that file system EC file system. It's like a same. One is with the eraser code, one is a normal. So we'll go normal. So file system. The kind is chef file system. So the name is myfs. And the file system is, there's a metadata pool. They have the 3 times replicated, and they have data pool. So the now file system object, the metadata is mentioned, or MDS pods will be created for taking care of the metadata, and the data is normal as usual. The three times data is replicated. So they can mention the compressed mode. A lot of other features are there. Anyway, we no need to worry. We just simply apply that one. So kubectl apply. It's outside. So file system dot YAML. First create the not a key. File system apply kubectl apply the file system outside. Now they created the chef file system. We can see through kubectl get chef file system. So we can see that there is a file system created, name is myfs. Now we created the storage class. In the storage class, we are referring that myfs. So I'm in the CSI chefs folder. Now I created kubectl apply -f storage class .yaml. So now I created storage class. Done. Now we check that how many storage class we have. kubectl get sc storage class. Now we have two spelling mistake. ctl. Now we have two storage classes. One for chef rook chef block. One is a rook chef fs. Two storage classes available. So whenever you want to create the PVC scan, these two storage classes either one going to provision. But we need some default storage class. So if we not mention that which storage class you want to use, we consider either one is a default. So that purpose, so we need to patch the one statement, one metadata. So this is a so kubectl patch storage class. Storage class you want to use it. I want the block storage as a default. So copy and paste that one. So chef rook chef block, and metadata is I'm annotated is a default class is true. Okay, I've just patched. Now we can see the kubectl get sc spelling mistake get sc. Now you can see that our chef block is a default storage class. So whenever the persistent volume provisioning happen, this storage class automatically used if you not mentioned. If you mentioned, suppose I want to use the rook chef fs, you need to mention that the YAML file is storage class equal to rook chef fs. Then this storage class will provision the your volume. So that's it. I want to say that. Okay, now look like our OSD is ready. Now we'll confirm one more time. Go to the tools and go to the shell on that tools. Now chef status. Now we can see that 3 OSD out of all 3 are up. So everything's so good, and there is a MDS also created. So MDS belongs to the metadata. That means for a chefs purpose. So one is up, and 3 monitor and 2 manager cluster also running. Now we go for the chef OSD status. Now you can see that before only 2 is showing, now all 3 is showing, because now we have all OSDs are up and running. So now we create a simple MySQL. Let's see, it's created by one of the chef. So we'll so go for Helm, Bitnami, MySQL. First need to Helm need to be installed. So we can through the git Helm chart install. So okay, now Helm is installed. Now I'm installing the MySQL for testing purpose. So I'm using Bitnami charts. First we add the Helm repo. So Helm repo is added. Now Helm install MySQL. Chart name is Bitnami slash MySQL. So now install the Bitnami. I'm not mentioning any storage class, so it's automatically created by the default storage class. Now I'll see that get kubectl get parts. Now you can see that MySQL is a container creating. It's take some time. That's okay, but we'll see the PVC, the persistent volume claim. Now we can see that persistent volume claim is bounded and it's provided by the rook chef block. So this is a default storage class. So it's automatically that 8 GB is assigned. It's a rewrite once access mode is created. Again, if you want to change just different storage class, you refer the Bitnami MySQL Helm charts. There is a one place called storage class. You can specify. By default it's empty, so it's automatically default storage class is taken care. So that's all. Chef installation part of that one. Next we'll install the Istio and we are exposing the dashboard what storage Chef FS have, that we can look at in the next video. And after the video we'll see the object. In future video we'll see that how to use the object storage provided by Chef, and we can use a S3 compatible client. We can able to communicate through S3 protocol. Okay, that's all. Thank you.